Hey again, class, it's Professor Rourke. Okay, I wanted to make a quick video because I didn't have any ones that applied from my previous semesters. And I want to make sure I explain to you as easily as possible how to approach some of the problems in chapter 9. Don't forget to use those guided notes for the interactive assignment. However, for some of those, they go into more detail about how to solve it by hand. And although that is helpful to sort of understand just kind of like how they're constructed, conceptually, you don't want to do that every time. Okay, you really don't. You just want to use technology because because technology piece is there, they have more topics that we do in our class. So although doing it by hand is a noble endeavor, you don't have to do that. And I just want to make sure that we're on the same page. Don't forget also that towards the end of class, the Canvas videos are super helpful for our class. So for instance, this is section 9.1 homework. I can see that at the top of the page. Then I could maybe, if I'm feeling stuck, I could maybe go to our class. I would open up the modules. I'm just going to go ahead and walk through how we could do that real quick. I would scroll all the way down past all these other chapters that we've done, and I would click the 9.1 resources and assignments. And this one, for instance, required resources, required is a little bit of a strong word, but it says how to use StatCrunch to compute a confidence interval and a margin of error for a population proportion. And that's exactly what this problem is as well. Okay, so those can be very helpful. And so just don't forget that they're there, please. Okay, so back to here though, just to make sure that we're on the same page. It says construct a confidence interval of the population proportion at the given level of confidence, and then it gives us some numbers to pick from. And before I even kind of look at the numbers, sometimes I just want to make sure that StatCrunch is an option because I talked a little bit about in the last video that I've made that sometimes StatCrunch can be a pain to open whenever it's pulled from a different textbook. So I just want to make sure that StatCrunch is there. You can always go back and open it and then come back, but the numbers sometimes change. So I just wanted to make sure StatCrunch was an option, and here it is. Okay, so now I'm going to go ahead and read the numbers so I don't change no, I'm not going to have to change the numbers on you. So it says construct a confidence interval of the population proportion at the given confidence level. Okay, so what this is saying is that X is 540. So that's like the number of individuals with the specified characteristic is sometimes what they say, right? And N equals 1200. Or 1,200. So again, just sometimes I think it's helpful to make up some context here. Okay, so for this one, I would say maybe I surveyed 1,200 people and I found that 540 of them like mint chocolate chip ice cream, right? I don't know, it's really random, but that's what we would be kind of being asked to do. And we could find the sample proportion from this, right? If we were asked to sort of, again, tying back to chapter 8, we could say, okay, then the sample proportion would be 540, right? Divided by 1,200. That is just kind of thinking about all the information that we have done sort of before now. Okay. Then again, if you look at the interactive assignment, they can show you how they can take this along with the z-scores to calculate the margin of error and by hand find the confidence interval. So that's why they have here, click here to view the standard normal distribution table, which is what I used to do back in the olden days when we did not have StatCrunch. We did have the graphing calculators, but my teacher didn't really do much with that. We would go into the back of the book, we'd find the z-score, okay, for this sample proportion, and then we would construct the confidence interval by hand. We don't have to do that, okay? So you can just ignore those tables. They're not bad. They're kind of cool, great, in the same way that it's cool to see how a radio works, but we don't have to do that, okay? So what we're gonna do is we're gonna go, everything in chapter 9 is we're gonna go to stat, and then we're gonna go to proportion stats, and then we're gonna go to one sample. Now, everything that's proportion is, I wanna say with almost certainty, is with summary. Okay, if it had the raw data, if we had the raw data, it would look like yes, 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 no, 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 yes, yes, I like mint chocolate chip, or no, I don't, right? It would be 1,200 of those. So list of that. So they typically will not do that to us. We will just have the number of successes is X. Okay, so that would type in 540. Next on here, we have the number of observations, which is 1,200. So we type that in. It says perform. The hypothesis test, we're going to come back. That's chapter 10. So, That's just where we're going to go for that one. It's really close, right next door. We're going to click confidence interval. Okay. And then we want to change the level. Usually it starts out at 95%. Unless you change it, we want 94%. Okay. So I'm just going to click 0.94 and then I don't have to do anything else. I'm just going to go ahead and click compute. I'll click just to kind of for our help, just to sort of help explain. I'm going to select optional graph confidence interval plot, just so you can kind of get a visual of what's going on here. Okay. And so what this means is that the actual confidence interval is the numbers on the right-hand side here. It says like proportion, count, total, sample proportion. So they went ahead and did that for us. They did 540 divided by 1200, it's 0.45, great. The standard error, which we, again, do not need to worry about. We're not going to need to worry. They're not going to ask you that. And then here they have the lower limit and the upper limit. So it tells us that the lower limit is 0.42298, and it says to 3 decimal places. So I'll say 0.423. Okay. And then it says the upper bound is just the upper limit, which is 0.477, also the 3 decimal places. So what this means is that we are about like 95, nope, sorry, it's 94. Let me go back. 94% confident that whatever they're talking about, the proportion of people who like mint chocolate chip ice cream, if we're going to go with that random example, is between 0.423 and 0.477. So like we're 94% confident that the true proportion of people who like mint chocolate chip ice cream is between 42.3% and 47.7%. Okay, which I think is a little high for mint chocolate chip ice cream, but it's just kind of made up here. And then I don't really like the way this one came out here. This, I have to double check why it came out like this. The 94% confidence interval plot, typically it looks a little different. So I'm gonna have to check to see why that didn't come out. But typically, like I feel like I'm gonna picture this as like a normal curve, not just like a flat line. I'm not sure quite why they did that. And we would be between, again, roughly 0.423 and 0.477. We would be 94% confident that the true proportion is in there. Okay, so I hope that made sense. Again, it was just sort of like a quick, like, here's how you do it on StatCrunch. Just want to make sure if you're confused, don't forget to check the videos out on Canvas page or send me an Ask My Instructor question. I can always make a video. I'm here to help. So I know 9 and 10 can be challenging, so please keep me posted on whatever I can help with. Okay, thanks class. Bye.